Hi everyone, and welcome to the MAT 211 review of probability density functions. My name is Julia, and I work for the tutoring centers at ASU. So, X has a normal distribution. The mean is 64, and the standard deviation is 2.5. We want to find the probability that X is greater than 61 and less than 65. So since X has a normal distribution, we're going to use a Z-table in order to find our values, our probability range here. So let's figure out what we know so far from our problem statement here. We've got the mean is 64, so mu is 64. And we've got the standard deviation is 2.5, so sigma is going to be 2.5. And we have these two values that bound our range of X values. So let's call 61 X1. So we'll write that over here. X1 is 61. And we'll call 65 X2, just to keep them clear which one we're using. Now, since we want to use a Z-table in order to find our probabilities, we need to convert our values for X into Z-scores or Z-values. So the way we do this is if we have some Z-score, this is equal to whatever our X value is minus the mu, minus the mean, divided by the standard deviation. So we can use this formula here to calculate our Z-scores that correspond to our X1 and X2 values here. So let's say that Z1 corresponds to X1 here. This means that we're going to have X1 minus mu over our standard deviation, which is equal to 61 minus 64 over 2.5, which is equal to negative 1.2. We'll do the same thing to convert X2 into a Z2, a Z value. So we've got X2 minus mu again over sigma, which is equal to 65 minus 64 over 2.5, which is equal to 0.4. So now that we have our two Z-scores, let's think about what this means. Let's draw a little badly drawn normal distribution here. So we know that if this is a standard normal distribution, which means it's a Z distribution, then our mean is equal to 0, and our standard deviation is equal to 1. So if we kind of roughly plot where our two Z-scores are here, Z1 and Z2. Let's say Z1's maybe about here-ish. So that's our Z1, which equals negative 1.2. And our Z2 is maybe, I don't know, here-ish, bad drawing. So there's our Z2, which is equal to 0.4. So the probability that X is between 61 and 65, it corresponds to the probability that Z is between negative 1.2 and 0.4. Let's write that a little more neatly here. Negative 1.2 is less than Z. It's a Z, there we go. Less than 0.4. So that's the probability that we're looking for. So we want to find this range in the center. So to do this, we're going to use a Z-table this time. So let's take a look at our Z-table here. The first thing to note, and let's erase this for now, come back to that later. The first thing to note here is that this particular standard normal table or Z-table, that's a same thing here, so Z table, is a left probability table. So what that means is that all the values given in here calculate probabilities to the left of whatever the Z-score is. So if you think of, like, you know, here's our 0, that's our median, this is some Z-score that we have here, then if we find this on the table, using, you know, the notations, you know, in this column for the, you know, main number and the first decimal, and this row for the second decimal, well, that number inside of here, whatever it is going to correspond to the area under the curve, which is the probability to the left of the Z-score. So the first thing we need to do is figure out where our values lie in this. So let's start with our Z1, which equals negative 1.2. So we would normally want to scroll down. You know, this will all be on one table here. But if we scroll down a little ways on our numbers here in this column, so we just went down here, we find that we have negative 1.2. Now notice that these rows correspond to the second decimal place. Well, negative 1.2 is equal to negative 1.20, right? So we want the first column here that corresponds to 0.00. So we would have this value plus this value. So negative 1.2 plus 0.00, well, that's negative 1.2, which is exactly what we want. So we'll trace our row corresponding to this guy, and we'll trace our column corresponding to this guy, and that lands us on this value right here. So our p-value, write it up here, we'll call it P1, which is our probability to the left of being to the left of this Z-score, is equal to 0.1151 from the table. And again, that is the area under the curve corresponding to this Z-score, corresponding to anything to the left of this Z-score. So in our drawing here, this would be this range in here. And that's not inside the range we want, but that's okay. And I'll show you why. Let's find our next value here. Let me erase these. We're going to scroll a bit further down. Usually this would be on the second page, so this would be the positive side of our Z-score values. Because remember that since we have a 0 here, we have negative values on this side and we have positive values on this side. So now we want to find our 0.4, which again, we can write this as 0.40. So if we look here, we scroll down, you know, or run our finger down the table until we find the 0.4 here. And we want 0.40 since we don't have a non-zero second decimal here. So that's going to be this column again. And we find that our probability here, which corresponds to the area under the curve, is 0.6554. So let's call that P2 so that we know that it corresponds with our Z-score too. So that's going to be 0.6554. So now let's go ahead and erase this. We don't really need those anymore. Now we have to figure out how we are going to combine these two probability values in order to get the full probability that we're looking for here. So notice, again, because this is a left-handed table, it's calculating probabilities to the left of the Z-score. This guy here is going to represent all of this to the left of our Z2 here. So everything all the way down. So notice that it covers the probabilities that we found in P1, which was to the left of our Z1 score. So what we can do by using a little bit of geometry here, we notice that if we subtract P1, which is this area, from P2, which is the total area here, then we'll get the target area that we want in between our two Z-scores. So let's see how that works. So remember that we have probability that 61 is less than X is less than 65 is going to be equal to the probability that our Z that corresponds with 61, which we found to be negative 1.2, is less than Z, which is also less than 0.4, which is the Z-score that we found that corresponded with 65. So this is going to be equal to the probability of our second, so our higher value here, since we're using a left-sided table, so P2, minus the probability corresponding to the left of our Z1 score here, P1, which is equal to 0.6554, and that's this whole range here, minus 0.1151, which is this range here, which equals 0.5403. And that equals this range that we were looking for here. So that is our answer. That is the probability that X is between 61 and 65. That's what we're looking for. Now note, it's important to note that we were using a kind of standard left table here. Sometimes you'll also get tables where the probability is given to the right of the Z-score. So you'll need to think about how you subtract your geometry in order to make this work for whatever range you are. So for instance, if we'd been given a right-handed table and some Z-scores that covered, let's erase all our little marks here, make this easier to see, boop, boop, boop. There we go, good enough, oops. All right, so if we had a, our Z-score or Z distribution here, we're still looking for this range in the center, but we had been given probabilities to the right, so then our probability corresponding to Z1 would cover this whole range, and our probability corresponding to Z2 would cover this range. So in that case, we would be wanting to subtract this probability from this probability in order to get the center probability that we're looking for. So it all depends on what sort of table you have. Now you can also do this with calculators. However, different calculators have different methods for doing this. And so the best way to go about this is to just Google the make and model of your calculator. So for instance, I have a TI-84 Plus. And then with that Google, also include like Z-scores or how do I find the Z-score or something like that. There's lots of YouTube videos and online instructions for every different type of calculator for how to do this. So just to finish up, this is our probability that we were looking for. And that's it, we're all done. Before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support at ASU, you can visit the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Additionally, if you're looking for tutoring for your specific course, you can use our tutor search tool, which you can find on our main website here, or by going directly to the tool at this full link that is on the screen. So thanks so much and have a great rest of your day.